Now let's continue with exponent rules, but I want to look at some things that have fractions involved right out the gate. That often makes it a little trickier for people. I think in this first one, what I'd like to tackle first, and again, this is not the only option by a long shot, is the negative exponent. I see that z to the -3, and I want to tackle that just because that's somewhere that a lot of people make mistakes. But I am seeing right away that you could combine some x's really easily, cancel an x out. So if that jumps out at you, do it. That's great. You could cancel a 4. So it's up to you. There's a lot of flexibility in this type of problem as long as you don't get addition or subtraction in the mix. To deal with the negative exponent, as you get comfortable, what's going to happen is it's going to push the z up to the numerator and make it a z to the +3. But a lot of people get tangled in that and forget and make mistakes. So I'd like to, again, go back to the basic, what's really happening there. So the top I'm going to leave just as is for now. In the bottom, I would like to think of that as 8 times 1 over z cubed times x to the 4th. And I'm going one more step with that before I fix it and show you how it ends up in the top. If we remember that 8 is really 8 over 1, and similarly with x to the 4th, we can multiply this together and say, okay, multiplying across the top gives me 8x to the 4th, and the bottom is just a z cubed. Now it comes down to fraction arithmetic, and the rule with fractions is dividing by a fraction, and we are dividing. Fraction bars are division symbols. Dividing by a fraction is the same as multiplying by its reciprocal. So we don't touch the 4z to the 5th x, but the denominator, the fraction in the denominator, flips upside down. And then again, if we remember that that's really over 1, we can multiply it all together again, and we get a -4 z to the 5th x times z cubed. And in the bottom, we're left with an 8x to the 4th. So notice from what we started with, the 8 stayed put. There's no negative exponent attached to it. The x to the 4th stayed put. And everything in the top stayed put. All that really happened there was that the z cubed ended up moving to the top and becoming +3 instead of -3. So as you see this, if you feel like, okay, I know where this is going, you can jump to that. But if in any doubt, go back to the basics so that you're not making mistakes with these. Now I think I'll go ahead with some of the canceling. I do see some nice pairs there that I can work with. 4 goes into 4 once and into 8 twice. So we can cancel a 4 out. With our z's, they're both in the top. So if I take 5 factors of z and then I multiply by 3 more z's, that's 8 of them total. So I have a -1 in the top and I have a z to the 8 in the top. And then the last thing to deal with there is x over x to the 4th. So again, you don't have to write this, but in my head, I'm picturing this, and I'm thinking I can cancel out one of those x's. X divided by x is 1. It does leave a 1 behind. There's nothing left in the top, but there are 3 x's left in the bottom. So in the bottom, I have the 2 and an x cubed. So kind of a lot going on here. Be very careful with these. These are important and something that tends to give people trouble all the way up through calculus. Let's do another one. This one I would say is even messier because there's some parentheses in the mix. We had a multiplication problem earlier that had some parentheses, and I distributed the powers through those parentheses first. I think I'll reverse that this time so you can see both ways. Let's do negative powers first again in this one. So the 12 is just a 12. It's really tempting to think that this -5th power somehow affects the 12, but without parentheses, it's not true. Exponents only apply to the one thing they're immediately hooked to. So in the next chunk of this, the 2k to the -4th, all raised to the -2, those parentheses absolutely do make the -2 apply to the 2 as well as the k, but here it's not true. So what we will have is just 1 over k to the 5th, and then we'll also have 1 over all of this gets moved down because of the parentheses. And then in the bottom, I have 6k to the 5th. Okay, I would like to mush this all together on the top next. So I have a 12, I have a k to the 5th, and a 2k to the negative 4 squared. Note, I should have pointed this out. I moved things into the denominator to fix that negative second power. That does not fix the negative fourth power. I could start to tackle that now, but you'd get some really scary looking fractions and fractions, so I'm saving that one up for a minute. I haven't done anything to the bottom. I think I'd like to deal with the complex fraction next. Again, I haven't dealt with all negative exponents, but I made a pretty good start, and I'm worried about writing more reciprocals within this horrible mess that I've already got. So let's deal with this first complex fraction, fraction and fraction. The top stays exactly as is. You multiply by the reciprocal of the bottom. And we can multiply that together. 12 on the top. On the bottom, I have k to the 5th, 2k to the negative 4 squared, and 6k to the 5th. Okay, so it's one fraction. Let's clean up that fraction a little, and then I think as my last thing, I'll deal with that final negative power. One thing that's standing out to me is ignoring the weird negative power k. I can combine those two. I have 5k's multiplied together in the bottom, and then at the end I have another 5 of them. So I can rearrange and think of putting them all lined up in one big stretch, and that's really 10k's, 10 factors of k, and you represent factors of k with powers. The 6 and the 12 I can cancel. So 6 divided by 6 is 1, 12 divided by 6 is 2, which means I'll be left with a 2 in the top. And then I think the last thing I want to do in this step, and you can absolutely split this into multiple steps if this is kind of a lot to do in one step for you, but I can square everything in the parentheses. So 2 squared is 4. I only square the 2 because of the parentheses. If they weren't there, that squaring would not affect the 2. K to the negative 4 squared is k to the negative 8. And now, again, you have a lot of choices. So we could combine these using the rule that says if you have two factors with the same base, they both have k as their base, you can add. If we're going back to basics and trying to understand what's really happening there, I would say, I'm going to move down just a little bit because I wrote that big fraction so big before, 2 over 4k to the 10th, and then k to the negative 8 is 1 over k to the 8, which means I have 2 over 4k to the 10, and that's over k to the 8. And now I can think about it as canceling. If I have, just looking at the bottom, 10k's on the top of that fraction and 8 on the bottom, I can cancel out 8 of them, and all that will be left is 2 of them in the top. So this is 4k squared, and that's over 1. If the 1's in the denominator, we don't have to write it. This is looking pretty fantastic. I'm going to take it just one step further. I can divide out a 2. So the simplest possible version of this answer is 1 over 2k squared. Okay, so kind of a lot going on. Again, lots of different orders you could choose there, but that's one run through this. All right, this is a little long, but since it's review, I think I'm just going to put all 3 of these fraction examples in one video for you. Last but not least, I actually think this one is less messy than the last one, but I wanted to make sure I got the whole variety. Here is the whole fraction raised to a negative power. So I think I will deal with that outside negative power first, but you could also simplify within the parentheses first or do a lot of other things. So that really means 1 over 4t to the 7th, u to the negative 3, over t times u, all raised to the positive 2. As soon as you take a reciprocal, it makes it a positive power. And that means, let's go ahead and get rid of the parentheses. So we're going to square everything. The parentheses mean apply it to everything in there. 4 squared is 16. T to the 7th squared is t to the 14. Remember, my thinking there is I have 7 t's multiplied by each other, and then I have to multiply all 7 of those by the exact same thing, which will give me 14 t's. U to the negative 3 squared would be u to the negative 6. Once negatives are in the mix, if I'm going to work on it that way, I do start to think about the multiplication rule a little bit more. And then on the bottom, the t gets squared and the u gets squared. So everything in the parentheses gets squared. This one is now really nicely set up for our fraction division rule. This is 1 divided by a fraction, which is the same as 1 times the reciprocal of the fraction. And you don't actually even need to write that 1 out in front. So there's what I end up with. Note that what happened was that all the stuff on the bottom got squared and pushed to the top, and all the stuff on the top got squared and pushed to the bottom. So really this negative power just flipped everything inside, and then the 2 squared everything inside. So you sometimes can start to see the shortcut for what's going to happen with that, but it's okay if not as well. I have 2 things I want to do now. One is I can cancel out some t's. There's 2 of them in the top. There's 14 of them in the bottom. If I knock out 2 of them, it will leave me with 12 t's in the bottom. And then the u to the negative 6, that's going to get pushed to the top. If in doubt, work it out for yourself. We have a u squared on the top. We have a 16t to the 12 on the bottom. And then that's a 1 over u to the 6. We can combine those 2 on the bottom so that doesn't look quite so hairy. U squared over 16t to the 12th divided by u to the 6th. 6, there we go. And then keep track of which is your big fraction bar. That's the big division. We need to take u squared and multiply it by u to the 6th over 16t to the 12th. And now we're getting pretty much there. When we multiply those 2 together on the top, that's 2 factors of u multiplied by 6 more factors of u, which is 8 total. And that is as nice as we're going to make that one. So you'll get a mishmash. Hopefully they don't get too crazy. I tried not to get too messy, but you will have some fractions and some parentheses, and we want to be really careful with those. Thanks for watching.